2015, paper 2, question 4, circle. So in question 4 here, we were given two circles, S and C, and we're told that they touch internally, and they touch internally at B as shown in the diagram. We're told the equation of the circle S is x minus 1 squared plus y plus 6 squared equals 360, and we have to write down the coordinates of the centre of S and also the radius of S, and we have to write down our radius in the form of a root 10. So for B part 1, then we're told the point K is the centre of the circle C. The radius of C is 1/3 the radius of S. So that means we can actually work out the radius of C. So the radius of C is equal to 1/3 the radius of S. So therefore we say or is 1/3 of 6 root 10. So the radius of C is going to be 2 root 10. Okay, so that means we know our radius of C there. So from B to K would be 2 root 10. And then we're also told the coordinates of B are 7, 12. So let's mark that in our diagram. So that's 7, 12. And we've worked out the centre of S. It's 1 minus 6. So let's continue that radius all the way down. So basically we have B and the centre of C and the centre of S are collinear. They all lie on the same line. So it wants us to find the coordinates of K. So let's just draw out that line there for a second. So we have our centre of S is 1 minus 6. And then we have K, the centre of C, and we have B, which is 7, 12. Let's just call that, and do B. So that's 7, 12 is better of saying. And we're looking for the coordinates of K. So we know that the ratio is that the radius of C is 1/3 the radius of S. So if I mark it on the diagram up here in the top, I mark it in green. So this distance from K to B is 1/3 the radius of S, which means that this must be 2/3. So basically, if we have our ratio, it's going to be 2/3 to 1/3. In other words, 2 is to 1. So our ratio here is 2 is to 1. So that means that K then is the internal divisor. And again, if we go to our maths tables for our internal divisor formula, we can see down the bottom of page 18 the formula that we are going to use to find K. So in other words, K is going to be B times x1, A times x2, over B plus A, B times y1 plus A times y2 over B plus A, where x1, y1 is going to be minus 1, 6, x2, y2 is going to be 7, 12, and our A is to B. So it's always A times the x2, y2, so you can see that's the opposite point, and B times the x1, y1, so again the opposite point. So let's sub in our values. So we have B, which is 1, times x1 minus 1, plus A, which is 2, times x2, which is 7. Sorry, I just made a mistake there. That shouldn't be a minus 1, 6. That's 1 minus 6. So that should be a plus 1 there. So apologies. So we have 1 times 1, and then it's over B plus A, so 1 plus 2. And then we have B, which is 1 times y1, which is minus 6, plus A, which is 2 times y2, which is 12, over 1 plus 2. So therefore K is equal to 1 plus 14, which is 15 over 3, and minus 6 plus 24, so that's 18 over 3. So that for k, the internal divisor is 5, 6. In other words, the centre of the circle, C. So we had 5 marks going for that. So we had 0, 2, 4, or 5. And we had 5 marks for A, which was broken down into 0, 2, or 5. So for part 2, we've defined the equation of C. So what do we know about C? Well, we've just found its centre. So we said its centre was equal to 5, 6. Okay. And we also have the radius, which is 2 root 10. So again, just going to our tables there on page 19, we can use x minus h squared plus y minus k squared equals r squared. So in other words, we sub in for our hk and our or. So we have x minus 5 squared plus y minus 6 squared equals 2 root 10 squared. So we have x minus 5 squared plus y minus 6 squared is equal to 40. So again, we don't have to square that out unless we're asked to, but if you squared it out, you'd end up with x squared plus y squared minus 10x minus 12y plus 21 equals 0. So there was 10 marks for that, for getting the equation. So we have 0, 4, 8, or 10. So then C. So C wants to find the common tangent at B, which I've marked in here. And remember, if we were looking at a tangent to the radius, it's always at 90 degrees. And we also have to give our form in ax plus by plus c equals 0 for the line of the tangent. In other words, we can't write it in the form of y equals mx plus c. So how are we going to do that? Well, we know it's perpendicular. So therefore, if we look at the centre of S, we know that's 1 minus 6. We know B is 7, 12. So that means that I can get the slope of that line containing those 2 points. In other words, the slope of the radius, let's call it. And if I write down 1 minus 6 and 7, 12, I can call that x1, y1, x2, y2. And again, if we go back to our tables, we can see our slope here is on page 18. We know that our slope is y2 minus y1 over x2 minus x1. So subbing in our values, we have m is equal to y2 minus y1 over x2 minus x1. So that's 12 plus 6 over 6. So we have 18 divided by 6 is 3. So therefore the perpendicular slope of the tangent would be equal to minus a third. So now we have the slope of our tangent and we have a point on the tangent because B is on the line. Then the equation of the tangent is the same way we would get the equation of a line. So again, page 18 of your maths tables there. If we go back, you can see the equation of our line is here. So we have y minus y1 equals m times x minus x1. So we make sure we write down the point and the slope next to it. So I'm putting in the correct value. So I'm always just making sure I'm subbing in the correct point and the correct tangent so we don't make any mistakes. So y minus y1 equals m times x minus x1, multiplying across by 3. So we get 3y minus 36 is equal to minus 1 times x minus 7. So 3y minus 36 equals minus x plus 7. And therefore in the form of ax plus by plus c, we get x plus 3y minus 43 is equal to 0. So in other words, A is 1, B is 3, and C is minus 43. So we had 5 marks going for that. So 0, 2, 4, and 5.